Welcome to Module 4 of the Piping Stress Analysis course. This is our crash course module, a fast, focused overview of 3 things every stress engineer needs to master before opening any analysis software: the input data you need to collect, the output deliverables you're expected to produce, and the overall analysis process that ties it all together. Let's get started. This module breaks down into 3 building blocks: the foundation you need before you ever touch Caesar 2 or any other stress analysis software. First, input data, the all-input datasets you must collect before building your 3D model. Second, the output deliverable, what actually goes into the final pipe stress analysis report. And third, the process, the step-by-step workflow, including what happens when a system fails and you need to loop back and iterate. Let's start with input data. Before you create your 3D stress model, there are 6 categories of input data you need to confirm. 1. Applicable design codes. This is set by the client's requirement. ASME is the most common, but always confirm it in advance. 2. Isometric drawings. You need the full system isometrics, including the preliminary proposed support locations. 3. Piping material specification. Your pipe spec, fittings details, branch connections, and corrosion allowance. 4. Piping insulation details, the insulation material and insulation density. 5. General project data, working and test pressure, ambient and design temperature, and wind and seismic data specific to the location. And 6. Equipment data sheets, the allowable nozzle loads for pumps and vessels, so they're properly factored into your analysis model. Get all 6 confirmed before you start modeling. It saves you from costly rework later. Once your analysis is finalized, this is the deliverable you prepare: the pipe stress analysis report. It needs to include the assumptions made during the analysis, a stress summary, a code compliance check, a displacement summary, the restraint summary, meaning support reactions, the spring design, if required, a summary of any system modifications, and finally, the updated stress isometrics with support markups. This report is the record of everything you did and why. It needs to stand on its own for anyone reviewing the design afterward. Now, let's walk through the analysis process itself. You gather your input data, build the 3D model in Caesar 2, and then check stresses against code and load requirements. This is the ideal path. If the system passes on the very first check, you finalize directly, no rework needed. But that's not always how it goes. More often than not, the system won't pass on the first try, and that's normal. Here's how you resolve it, in order of least disruption first. Option 1. Adjust supports. Change support types or locations. This has the least impact on the piping arrangement and on the hydraulic and layout engineers, so always try this first. Option 2. Reroute the piping. If adjusting supports alone isn't enough, you reroute, most commonly by adding an expansion loop to absorb the excess stress. Option 3. Repeat the cycle. Recheck stresses after every change and keep iterating between supports and rerouting until the system passes safely. Putting it all together, here's the complete workflow. Gather your input data, build the model, and check stresses. If the system doesn't pass, adjust supports or reroute, then recheck. Repeat that loop as many times as needed. Support changes, then rerouting until the system passes. Once it does, update your drawings and finalize the report. Let's wrap up with 3 key takeaways. 1. Collect all your input data sets: codes, isometrics, piping and fitting data, equipment data, and project data before you start modeling. 2. Your final report must cover the design basis, stress summary, support reactions, and any modifications made. 3. Always resolve failures with support changes first. It's the least disruptive fix, so try it before rerouting or adding expansion loops. That wraps up Module 4. Next up in Section 1, an introduction to Caesar 2 software. See you there.